In physics, we deal with a number of quantities, which are measurable. These are called physical quantities, like length, mass, and time. A meter ruler, stopwatch, weighing balance, and thermometer are used for measuring purposes. There are two types of physical quantities. Base quantities are those fundamental quantities that are not obtained from other quantities. These are 7 in numbers. Whereas derived quantities are that which derived from multiplication and division of 2 or more base quantities, like speed and area. Every measurement required a standard unit to measure. For this purpose, a globally accepted system is used, which is called a system international of units. It is modified for the m.k.s system in which we have only 3 base quantities, but in System International 4 more quantities are added. Based on this system, we have 7 base units for base quantities, which are given in the table with their symbols. Here kilogram is for mass, meter is for length, second is for time, Kelvin for temperature, ampere for current, mole for amount of substance, and candela for luminous intensity. These are standard units, and all other measurements are calibrated in terms of these units. Every measurement includes these base quantities to express their measured values to some standard. For example, derived quantities are expressed in terms of respective base units. Like speed, which is obtained by division of 2 base quantities distance and time. For distance we have base unit meter and for time is second, then derived unit of speed is meter per second. Similarly for force kilogram is unit of mass and meter per second square is for acceleration, so derived unit of force is kilogram meter per second square. Prefixes are used before a unit. These are specific values written in scientific notation. For example, kilo has a specific value of 10 power 3, which is specific for kilo only. It is represented by K symbol, and we just T by looking at symbol understand that unit is in kilogram or kilometer. Some important prefixes are given in the table with their values and symbols. Some of them are kilo, mega, milli, micro, and nano. Prefixes help us to write very large and small measurements in symbolic form. To measure physical quantities, we use a number of measuring instruments. For example, very small lengths and thickness are measured by vernier calipers, who measured quantities up to 0.01 centimeters. This is called least count. For more accurate measurements, we use another instrument called screw gauge, whose least count is 0.001 centimeters. To measure time-dependent quantities, we use stopwatch. Internationally, atomic clock is used to define 1 second, in which cesium atom vibrations are considered equivalent to 1 second. In measurements, we use 2 terms, accuracy and precision. Accuracy means measured value close or equal to exact value, whereas precision is how close measured values are to each other. Not every measurement is accurate and precise. This happens due to some errors, which are systematic error due to faulty apparatus, random error which is due to some external effects like wind, friction, etc., and third is personal error which is due to human negligence during measurement. To get accurate measurement, we eliminate these errors by number of ways. For example, by taking mean value and absolute value of the measurements which are made. For example, 3 different values of time are given, and we find its mean, absolute, and then percentage error. Mean is found by taking the sum of all measurements divided by the total number of measurements, then to find the percentage mean value is divided by the original value and multiply by 100% to get percentage in error. In this way, any error in measurement can be eliminated. This concept is highly asked in NEET exams. After measurement, our main concern is how to write answers, it means up to what figures. This is done by concept of significant figures, in which we count every non-zero digit as significant, whereas zeros before a number are not significant, and if there is decimal between numbers, then all zeros are significant. To check the correctness of the equation, we use dimension analysis. For example, m is dimension of mass, L for length, and t for time. For example, velocity dimensions are L per t. Dimension of force is found from formula F equals ma, where dimension of mass is m, and for acceleration, it is L per t square. Dimensions help us to find the relation between physical quantities and then use to analyze the correctness of formulas. For example, we have an equation of motion, where distance is equal to velocity into time plus half of acceleration into time square. Here, the left-hand side is equal to L, which is dimension of length or distance, whereas in the right-hand side, dimensions are 3/2 L. So neglecting constant, we are left with L, which is equal to left-hand side, so equation is dimensionally correct. At the end, I have 2 MCQs from NEET 2022 past papers where 2 questions are asked related to dimensions and significant figures. Comment to get more questions and for any help.